Probability. Probability. Miss Wilkerson.
Sorry.
Probability. What is probability? So when we start talking about, so we already talked about likelihood a little bit. We have relatively talked about probability. But what are some situations out in the world that you've encountered where probability comes into play? Or what are some situations where you've ever felt, wow, that was really lucky, or wow, I had a really small chance of that? Colin?
Like, for instance, like, when you're playing like lotteries, but with numbers, you have the cards, and you get lucky that you get a number that's picked, and then it's 5 in a row, you're like, wow, that's really lucky. That's a very low probability, so that could be unlikely.
Yeah, so if you actually, like, win something, right? Like some kind of contest, a drawing, a 50-50, a raffle, whatever.
Like, 100 people submitted, and you're the one who got it.
Yeah. Tom?
I was playing Yahtzee with my family, and I had.
Now, what's Yahtzee use?
Yahtzee uses how many? Is it 5 dice?
Yeah.
It uses 5 dice and you shake them off randomly. And so I had nothing on my second roll, so on my third roll I just rerolled everything and I got Yahtzee.
So what's a Yahtzee?
A Yahtzee is when all the dice and they're all the same number. So you can have all 5 are 1, all 5 are 2, all 5 are 3.
So we can actually talk about the probability of 5 dice having the matching, a matching roll, and we could compute how likely that is. Andrew?
Also with rerolls, that might be different too. But anyways.
Well, but he re-rolled all of them. So, yeah.
And I was gonna say the
4 games lottery, Ozzy?
I was playing this game called Catan.
Yeah.
And I kept on getting 7s.
That's actually the most likely roll in Catan. So if you think about rolling 2 dice.
In any dice.
So we can create probability tables, and we'll get deeper into this, but because you brought up rolling a 7, Catan, or not even Catan, dice roll table. So this is the outcome of rolling 2 dice in all possible options. Notice there's only one way to roll a 2. There's only one way to roll a 12. But this entire diagonal line, these are all 7s. So there are 6 ways to roll a 7, whereas only 1 way to roll a 12. So when you're looking at what's my probability, well, how many ways can you get what you want out of how many different ways could I get a result? There's also a probability that went into effect that I can't believe we're not thinking of. You all being here.
Oh, yeah. Probability.
So, depending on the amount of people from your district area, male or female, determined the likelihood that you would end up here. So, well, it depends on your district area. So some people, literally every boy from that section got pulled. Some places, only a fourth of the boys on the list got pulled because so many applied. Now I'm making these things up, but this is what actually happens. Because if the list is really small, we still pull even amounts of distribution from the different areas. So split the district, sides of the river, male, female. It's a bit more complicated than that, but if you want to understand, that's how we do it. Yeah.
Have you ever had so few people apply that you've had extra spots?
Nope.
Ever?
Nope, never. We normally have about double apply as what we can fit. So likelihood and probability. Really, probability is the mathematical way to express the likelihood of something happening. So if I think about rolling 1 die, Moon, what's my chance of rolling a 5? You're not listening. How many ways are there, or how many outcomes are there on a die? 6. How many of those outcomes is a 5? So what's your probability? 1/6. So when we talk about probability, we have a range. Like about the start slide, you don't have this on your notes. 0 means it's absolutely impossible. What is the likelihood that I will grow wings and fly out of here? We know that can't happen. Well, it's never happened. So for what we know, in theory, based off what we know, it's impossible. All the way up to a probability of 1, which actually is what percent? 100%. When we talk about probabilities, we almost always talk in rate form, so we either use the fraction or the percent. So, what is the probability the Earth will go around the sun, or you will write a best-selling novel, or tigers will fly, or it will rain this week, or your team will win the big game? So, your friend says probably to to all of these. Can we use better words? We're not going to the math yet, but can we use better words for describing how likely these things are, as opposed to just saying, probably. That gets really annoying because that doesn't tell you anything really. Honestly?
So the Earth will go around the sun would be very likely, like completely certain.
Ooh, so when it's all the way beyond likely and we know it's going to happen, we call that
And
certain.
What the science
you will
was.
write a best-selling novel. That kind of depends on who you are.
Okay. So,
You also might.
So
even if you're a really good author, are you necessarily writing bestsellers?
No. So there's like a 50-50 chance.
Even if you're a really good author, do you think it's a 50-50 chance?
Yes.
It's really hard to write a bestseller.
I don't know.
How many trash books? Well, how many books did she say didn't get published?
5.
I think it was even more than that.
7.
So really, the fact that you would have a bestseller, really we would say is unlikely. I like your positive attitude, but in all reality, for anybody to write a bestseller is unlikely. There's so many books out there. And for you as a middle schooler to write a bestseller, it's very unlikely. But we'll give you some benefit of the doubt and just say unlikely.
Tigers will fly is impossible.
It is impossible.
I'm gonna make a tiger fly when I get
It
older.
will rain.
Now, the problem that we always have is you as a slightly immature middle schooler, it's okay, that's allowed, you're in middle school, you want to try to rationalize the other side at all times because that's just your ornery kind of nature, being like, well, I bet I could. Don't tell me I
No,
can't
I
do
actually
that. Like,
probably. I'm gonna try that.
yeah, and the fact that you keep interrupting me is just more definitive to back up my point. So, based on what we know, scientific evidence, we're talking about those probabilities.
It will
So, now when we look at it will rain this week, well, it depends on the season, but now we know what season are we in.
Like
Spring.
Spring. Yesterday was the first day of spring.
like
So, what's spring known for in Ohio? Rain. So, it is likely that it will rain this week.
your team will win the big game.
Your team, like.
So let's talk
basketball.
NCAA. Your team's gonna win the big game. Whatever team you got tonight.
Unlikely.
I'd give it, depending on your team, I don't know, at this round in the tournament, I say they're all coin flips. At this round in the tournament,
It actually is a coin flip because there's a 50-50 chance.
well, there is some, like, ranking that goes in, so it's not quite an even chance, but because upsets are possible, in my mind, now you don't have to agree with me. You could write down one of those other words. You don't have to agree with me, but in my mind, I think it's a coin flip. It's an even chance. All right, so here on your paper are some examples of how we use those words for, so like statements that are said using those words. So like a playoff spot for the Wolves is impossible. Or now that Villanova lost, winning the whole thing is impossible. They already lost. So you've got, come on, you got some of those examples right there. Scrolling on down through, now we're hoping that we make it to 16.2 today. We'd like to speed up even more in this chapter. So use those words and give each of these a probability for you. What probability you think these will have. There's not necessarily right or wrong. There's better versus worse, but
We'll see what if we're using something.
Hmm?
Because we're number one, that would be a certainty.
Oh, wait, actually, growth is in like 1 or something.
still we've never seen anyone grow 5 inches of hair in a
that's what I'm
day.
saying, unlikely.
And we can always use the word vary to push it further down the scale.
What's the chance that you're gonna land on me when you pull one of those cards? How many
Right now, it would be 1 out of however many cards are in there. And because you know that I'll skip anyone not here, it would be 1 out of the number of people that are in the room.
Sweet.
I'm going to do cards for all these. Colin, what do you have for the probability that you will go swimming on a hot summer day?
I said likely because you're made.
Good morning, Phoenix. Please pardon the interruption. Whitney Marshall, please come to the office. Whitney Marshall to the office, please. Thank you.
Yeah, so I like what Colin is saying. You might not feel like going outside. Maybe you went to the pool yesterday and you spent all your money. So I would be very cautious to use the word certain. Certain means without doubt this is going to happen. Yeah. So like even what's the probability that I'll go to sleep in my bed tonight? I still wouldn't even say certain on that because some nights I end up camping. So I do not every single night do that. Hey Jeremiah, can we not? Because that's just how we end up with Powerade all over everything. Right? Like why? So what was your intention behind that?
To pull this wrap thing off.
Okay, but so do you understand how that is obviously showing me that you're essentially not caring at all about what we're doing? It's just like the respect thing. It's like if you came up to me to ask me a question and I start knitting. You know what I mean? Ellie,
Hi.
over there will be children wearing costumes on Halloween.
I said likely because, I mean, now that we're getting older, I don't know what children is classified as, but some kids don't even like to go out on Halloween.
Is this talking about you?
Not teens, children. So,
Okay, so probably them.
I did certain.
So if we're just talking about there will be children, it's not telling us who, it's not telling us where, it's just anywhere,
Then, like,
any kid. I would actually go ahead and call this one certain.
That's what
Now you don't have to.
anywhere, not America.
You know, like you can disagree. You could say there might be a Halloween where nobody decides to dress up, but I don't believe that's going to happen. I think if I go out on Halloween, I can find a kid dressed up in a costume.
What if
Is there not? Is there
Elena, what about your hair will grow 5 inches in one day?
I think very unlikely.
Very unlikely. You flip a coin and it lands heads up. Moon?
I said even chance.
Even chance. And what is a synonym for even chance?
50-50.
50-50. So when you hear people say a 50-50 chance, that's an even chance. And Mana, so what about a student in your class will become famous next year?
Unlike.
Is it impossible?
No.
It is not impossible, but it is unlikely. And if you could say very unlikely, but honestly, we're in Columbus. We're a pretty big metropolis. People could end up on TV. People could end up on YouTube. I would just really leave it at unlikely because I mean it could happen. You don't know. I mean, no, I can't think of her name offhand.
Jacob Sartorius.
No, has a YouTube channel. Posts a bunch of videos. No, she's got more subscribers than I do. Grace, thank you. Gosh. Grace is YouTube. Who knows? Maybe Ellen DeGeneres sees her YouTube channel and invites her out to California and she becomes famous. Could happen. Not very likely, but it could happen.
Yeah, Anthony has over 500 subscribers. He used to be.
just with a video that's like
As long as you keep up on your homework, I don't care. Alright, so when we bring numeric values into this, fractions, decimals, or percentages, this is the range that we work under. So if we're talking 0 to 25, that's pretty unlikely, all the way to very unlikely. 25 to 50 gets more likely, kind of in that probable range, somewhat likely, somewhat unlikely. 50 to 75, same sort of thing. And 75 to 100, we're working our way to certain. I don't want to move that. Okay, flip to the back. So try this out. So when you're looking at those flags for probability of a stripe, how many flags up there have stripes? So go through, do a little notation on them or something. Groups of people love it when you count out loud. If there's anything I've found out about groups of people, 100%. How many flags did we find with stripes, Moon? 12? Anyone verify that?
Well, I have 14.
I found 13.
Guys. Alright. 1, 2, 3, 4, 5, 6, 7, 8,
Yes.
9, 10, 11, 12, 13.
Oh, oops, I counted the one up there.
13 out of how many total flags are up there? 20. Here's one way that I can make that easier. Get that to 100 on the bottom. How would I get a 20 to 100?
Multiply it by 5.
Multiply by 5. 13 times 5 is 65, which is how I end up with 0.65. Which I could write reduced as 13 twentieths, or we could just say 65%. Questions on that? What about, Jaslyn, probability of a flag with a triangle? Alright, I'll give you a second. Oh, sorry, let's back up. Moon, since you helped me on the first one, what would you classify that as? The verbal that we would say for that? Likely, yeah, it's more than 50%. It's likely. So, flag with a triangle, Jaslyn, sorry, how would you classify that, like, verbally? Unlikely? There's less of them? How many did you find?
I found 10.
Ooh, okay. That's a lot of 10. Now, I put her on the spot. I made her count really fast, so I'll take the blame on that one. So sorry, I should not have asked you to do that so quickly. Shows that you should take your time. So, if there's 10, how would we verbally classify that? Yeah, 50-50 or an even chance. So, there's 10 out of 20. They also show me my 50% over here. So, that could be 1/2 or 0.5, if I want to write that out in the other ways that we could write it. And probability of a circle is already given to us as 1/5. So, Sean, if you had to not hear, Samantha, if you had to give a verbal chance for 1/5, unlikely. A 1/5 chance is not very likely. Unlikely. That is 0.2 if I put it over a 10 or 20%.
That's not a horrible chance.
Not, I mean, depends on what you're looking at, right? So 20% chance. If I have a 20% chance to win the lottery, that's awesome. If I have a 20% chance of mastering this test, ooh. So it depends on what we're looking at. That is not going to work that high up. I can't reach that point of my board. not working out. So try the got it in reduced form, and then we'll look at the example. I'm going to try to orient my board again or something.
What
Good morning, Abby Needleman, please come to the office. Abby Needleman to the office, please. Thank you.
was the verbal one for like the fact, the triangle?
We said 50-50. We had said unlikely. Then we realized there were actually 10. My smartboard hates me. I think there's ghosts in the building. Do you need something? You're just hanging out. Alright, so if I have a 0.15, we can actually easily convert that into a percent. Colin, what's the percent for that?
So percent would be 15%, and the fraction is 3 over 20.
It's possessed. I'm gonna move my
Smartboard is
projector just a bit. This probably won't work because it's not functioning. I've got a couple dead. If you want to be technical, when we talk about probabilities, we use fractions or decimals. A lot of people end up talking about them in percents. When we talk about probability, it is supposed to range from 0 to 1. So the percent form is kind of like an extension. So, moving on down, check out the final example. So, planes. Planes, and anyone ever experienced this where they tell you your flight's overbooked? So, we were on our way to the wedding in California, and I wish that we had more time, but we wanted to get to California. If this was on the way home, I probably would have done this, but they came on the announcements. They said, "Excuse me, ladies and gentlemen, if you would like an opportunity to upgrade your flight to a first class, get a free meal, and da-da-da-da-da, please come to the flight kiosk." They had overbooked our flight because they assume a certain amount of people aren't going to show up because people book flights and then their plans change and they don't make it to their flight or they sleep in or whatever. They miss their flight. Unfortunately for the airline, if that doesn't happen and everybody shows up, your plane can't take everybody. So you convince people, first class upgrades, free meals, free tickets, free vouchers. You convince people to not ride that plane and you put them on the next one. So they assume that the probability of a no-show is 10%. 10% of the people that book tickets don't show for this certain airline. So, on which flight should the airline expect to have more empty seats? So, for the first flight, they sold 210 tickets on a flight that's supposed to house 200 people. On the second flight, they sold 330 on a flight that's supposed to house 300. Which one has room left in their overbooking? So they want to overbook by 10% is what they're saying. Well, if we look at our first flight, supposed to have 200 seats available, like when they start, what would 10% of that be? How many people do they expect to not show? 20. So flight 1 could have actually sold how many tickets?
220.
Okay, I was talking with Noah, but yeah, 220. If I assume that 10% won't show, that 10% or 0.1 of 200 is 20, so they could have sold 220, so we will think that they might still have 10 seats available if 10% don't show. Now, on my second flight, my larger one, Jeremiah, how many would be the overbooking range on that flight?
Actually, 330 tickets is 10%. No, 33 is 10% of 300, so they would have like.
Ooh, hold on, back up. What? How much is 10% of 300? I think you might have done 10% of 330.
Yeah, that's what I did.
But the flight only has 300, so that's our whole that we use.
Then it would be
30?
Yeah.
Did they sell all their overbooking tickets? If they sold 330 tickets, Did they sell the plane empty?
Yeah,
Did they sell the 10 extra percent?
I think so.
Yeah, if they sold 330, they sold that extra 30. There's no room left here. Actually, they'll probably end up in a situation like my California flight, where they're trying to get people to switch flights. Now, they want the plane to be totally full. They want every seat filled, and actually it's better for the math of the plane. They'll literally get on the plane if it's not very full. This is a decent example. There's 6 of you over here and 4 of you over here. If I'm the flight attendant, I might be like, excuse me, man, could you move over to this side to balance the plane, please? They literally balance the plane if there's too much weight on one side versus the other. So 6 people versus 4 people, I'd want 5 on both sides. But they'd rather no empty seats, and then your plane's balanced.
There was one time, I was maybe 2, so it was like 10 years ago, but we were flying back from Florida and a bunch of people didn't come, so we each had a road horse.
Yeah. Those flights,
They don't
the airline probably lost money. But they gotta get their plane to the next place. So even if the plane isn't full, they can't just be like, oh, we're gonna wait and combine you with the next flight. That doesn't work. There's a whole series of where the plane needs to be.
Because people
And
in the
you gotta
next
get
place
out of
might have
there.
booked the same flight.
What's that?
People in the next place where it's supposed to be might have booked the same flight.
Right. So, 16.2 takes some of our ideas from, we were talking about populations and samples, and now it is going to get us working in sample space and how we determine probabilities. So, to determine a probability, we first have to understand what our sample space is. And if we want to relate this to statistics, our sample space is kind of like, it's kind of the size of the sample that we look at. So, remember when we talked about statistics and we said, what's the probability of a girl at Phoenix? And if I look at this class, right now, 1, 2, 3, 4, 5, 6, 7, 8 out of, or compared to 1, 2, 3, 4, 5. So we have 8 out of 13 in our sample. 8 out of 13. Is that true compared to Phoenix? No. So our sample is not representative. In probability, we don't care about representative or things that our sample space is possible outcomes. So on a die, what's our sample space? When you're rolling a die.
6.
Close. You're on the right track.
Big die.
So our sample space has all possible outcomes. So you're thinking there are 6 outcomes. Our sample space is 1, 2, 3, 4, 5, 6. We have to talk, name all the outcomes.
Aren't there only 6 outcomes? 'Cause there's
Yeah, but you
6
can't just say 6, because then that makes, there are 6 outcomes, but our sample space exists of 1, 2, 3, 4. Like our sample space for a coin is heads, tails. You wouldn't say it's 2. You'd say it is heads, tails. Does that make sense?
Or it has 2 outcomes.
Yeah, but when we talk about sample space, we list out the outcomes. So, our sample space here is a modified dartboard. Your friend's board, you're hanging out in the basement, whatever. You decide to make your own dartboard. Maybe you'll throw your little brother at it or something. So if you hit the white spaces, you if you hit a composite number, you get a point. If you hit a prime number, I get a point. So your friend gets a point when you hit a composite. You get a point when you hit a prime. What are our primes up here? Are our primes? Those are our composites, right? So these are all composites. 91 is our prime. Because 48, 64 evens, easy to tell. 57 can be divided by 3. So these are all composites. So what's the probability that you gain? So I'm going to teach you guys probability notation for a second really quick. Yeah.
What's a composite number?
It is, it's not prime.
Oh.
So-
any number that's not prime.
So prime only divisible by 1 in itself. Only evenly divisible. So, what's the probability that you gain a point?
It's like
25%.
Ah, it's 1/4, right? Because only the prime number gains you a point. What is the probability that your friend gets a point?
Yeah, 3/4.
3/4. So, based on understanding of probability, who do you think will win?
Your friend.
Your friend.
Well, I mean, you might have taken into account that he's a better shot and gave himself a handicap. Just to make it more fair, because maybe his friend sucks.
But that is a prediction based only on math.
Oh, I know. it
That
makes
is
sense.
not taking into account skill. So, no skill is involved. We're just talking about probability. Now, if we then talk about, I've been playing darts for 10 years and my friend has never picked up a pointed object. Like his parents don't trust him. So that would change the game, but just based on probability and region outcome, you got a 1/4 chance, your friend has a 3/4 chance. Don't clear capture first.
Why do you always capture?
Because then the PDFs I can upload or do whatever. If people miss class, I can email them the notes that are completed. So like they can just have the PDF and not have to watch through the whole thing. So here's our number cube. So the sample space, this is what I'm talking about, so I would highlight if I was you. The sample space lists all outcomes. So an action is what you do. So in this case, the action is roll. I can flip, I can draw, I can roll, I can select, whatever. Essentially, it's a verb. It's an action word. I mean, depending on the situation that you're talking about, could be. Like if you're blindfolded, spun around, and there's like different colored soccer balls or something, like what's the probability that you kick a blue one? Or I mean, you can make any sort of situation. So the outcome is what we're looking for or what we're investigating. So the outcome could be like a 3. So if I roll a 3, sorry, that A makes that seem a little weird. And my sample space is all of them. So how we write probability, and this is beyond what you have to learn this year, but we might as well teach it to you now. We would say P for probability of, in parentheses, put the outcome that you want. So the probability of rolling a 3, how many 3s are there? 1. How many are in the sample space? 6 total. Or how many outcomes are in the sample space? Sorry, I should have been more clear. So we have 1 3 out of a sample space of 6. 0.16 with the 6 repeating, or approximately, if I round, what percent?
16.
Oop.
17.
If I round, it would be 17. Questions?
I didn't get the paper, I was in the bathroom.
Right here, always right over here. And hours just go kind of upside down, up above here, because then they get used for the other class when they get there. So I'm digging through an old crate, and I find some buttons. I wish, because my buttons, I had 3 buttons fall off the same shirt. Very sad. So we put these buttons out, and we have our action of choosing a button. The outcome that we're looking for is maybe a tan one. So if we say, what's the probability of choosing a tan button? So we'd say, or whatever color you interpret that to be.
I think it'd be gray.
Gray.
On my paper.
Well, yes, your paper is in grayscale. So, Evie, thank you for volunteering. How many gray buttons are there? 4. What is the size of my sample space? How many outcomes are there possible? 10. So we get 4/10, or 0.4. or 40%?
You guys read out all of them for a test?
I mean, I might ask for it in a specific way. I might say, what's the fraction probability, or what's the, I mean, a lot of times it's your choice, but depending on how we're using it.
We're probably getting through the whole first page.
Oh, yeah. I mean, we only have like 4 minutes left, but yes, I agree. So, sorry, a lot of this isn't capturing, it just keeps deleting itself. So, probability of rolling an even. How many evens are there on a die?
There's, I don't know how many actually.
So we can just do fractions now. We don't have to write out every form. Well, there's 1, 2, 3, 4, 5, 6. So 2, 4, 6 are evens. 3 out of 6, or that could reduce to a half. Probability of rolling a 3 we already talked about is 1/6.
My name on this.
Probably should.
Oh,
Good idea. Flip to the back. So the band director chooses one trumpet player at random to lead the band in the holiday parade. What is the actual sample space here? Ah, the trumpet players.
Tired, Mr. Hudson.
So, to look at how many outcomes there are possible, well, how many trumpet players do we have in our band?
Oh,
Good question. We should know this.
Jared, Bella, Atticus, Colin. 6. No, more. What?
Aiden, Julian.
So, we don't have to fight over this for a while, but sure, 7. Maybe there's 7 players that play trumpet.
We're getting one more.
So, the probability for any one of them, so like if we said the probability of it being Julian,
It's 8.
It-
43 minutes.
if you want to change it to an 8, you can. It'd be 1 out of 7, or 1 out of 8, whatever, however many total there are, it's you are 1 out of the total possible outcomes. Check out this spinner below, numbered 0 through 9. Our action is 1 spin of the spinner. Our sample space is obviously all outcomes. So let's say, what's the probability of an odd?
Ooh.
How many odds are there up there?
There's, I don't know. 5?
1, 3, 5, 7, 9.
5.
Out of how many total?
9.
2, 4, 6, 8. Also 0.
Wait, I thought 0 was neutral.
It's not odd.
Wait.
Is all we care about. It is not odd. It does not fall in here. So, but it's not even either. So your probability of rolling or spinning an even would be 4/10, because 2, 4, 6, 8. 0 doesn't count. Depends on how you classify it. We could also talk about many other probabilities. That's the basics. That's all what you need. We'll pick up here tomorrow. Thank you guys.
I like